Welcome to the AI Research Roundup. I'm Alex. Today, we are looking at a paper from the Hugging Face trending list, published on September 11th, 2025, which was about 4 days ago. The big idea is a massive, in-the-wild video dataset with explicit three-dimensional grounding, totaling 2.7 million annotated clips and 7,089 hours, that pairs per-frame camera poses and depth with motion labels and rich captions. The paper is titled SpatialVID, a large-scale video dataset with spatial annotations, and the implications for model training are quite significant. Beyond scale, the dataset supplies structured motion instructions and high-quality spatial annotations that enable controllable, geometry-aware video modeling. On X, posts highlight the dataset's scale and annotations, stressing 7,000 hours per frame poses, depths, and motion labels that improve generalization with moderate engagement, roughly 128 likes on a popular post. Those posts emphasized scale and motion labels, and Figure 1 now lays out what that scale contains. The left cube visualizes scope with 2.7 million clips, 7,089 hours, and 127 million frames, which signals coverage broad enough to train generalizable models. The right panel summarized the pipeline from raw video to clips with camera poses, depth, dynamic masks, and motion instructions. The structured caption block shows multi-level text, so models get both geometry and rich semantics in one package. So the previous figure summarized scale and annotations, and Figure 2 shows how those clips are curated end to end. The Sankey style diagram traces raw videos through pre-filters for broken files, title checks, and size mismatches, then into clips that pass aesthetics, luminance, OCR, and motion filters. High-scoring clips enter dual annotation, which adds camera poses, depths, masks, and captions. The pipeline finally yields the main dataset and a SpatialVID subset, so quality and motion balance remain controlled across categories. Alright, the previous figure traced the curation pipeline, and Table 1 compares datasets head-to-head. The table lists domain, whether data are real or synthetic, dynamic or static, geometry info like camera and depth, caption type, and scale and clips and frames. The key point is that SpatialVID and SpatialVID are dynamic, real-world, and include both camera poses and depth, with structured captions, which most others lack. The scale also stands out, with about 2.7 million clips and 127 million frames. Well, the previous table contrasted datasets, and Figure 3 presents the end-to-end curation workflow. The left filter pipeline shows raw web videos passing, pre-processing, and hierarchical filters so only motion-rich clips survive. The central annotation pipeline adds camera poses and depth, derives motion instructions from those poses, and fuses Gemini and Qwen captions into structured scene and camera descriptions with tags and summaries. The right sample pipeline then balances motion and categories, which yields the main set plus the SpatialVID subset. Alright, the previous workflow covered annotation and sampling, and Figure 10 presents what those choices produced in motion balance. The left donut summarizes SpatialVID, where forward accounts for about 1/3, so some directions dominate. The right donut shows SpatialVID, which distributes motion more evenly across forward, right, left, and mixes, reducing bias. This balance matters because models trained on it learn camera control that generalizes, rather than overfitting to mostly forward motion. Wrapping up, 2 takeaways stand out. First, pairing per-frame camera poses and depth with motion instructions at massive scale gives models explicit three-dimensional grounding, so controllable video generation and dynamic scene understanding become more reliable. Second, the balanced SpatialVID subset curbs motion bias, improving generalization. That is it for the AI Research Roundup. I am Alex. Thanks for listening.